Here is a look at the Vector Q's user interface. The data being displayed here is from a live power environment inside an electronics assembly facility in central North Carolina, which has a Vector Q installed at the panel level. The colours black, blue and red represent phases 1, 2 and 3 respectively, and are consistent throughout the entirety of the dashboard. Let's take a look at each section of the dashboard. The top left displays the input voltages. Below that shows the current in amps. On the bottom left, you see a bar graph of harmonics on each phase for the first 11 harmonics, displayed in logarithmic values, with the yellow bar being an average of the 3. The top right is the phasor diagram, displaying the real-time relationship between current and voltage across all 3 phases. The voltage is shown as the fixed arrows at the 0, 120, and 240 degree positions. The current in amps is displayed by the length of the other same coloured arrow. The longer the arrow, the greater the current. The greater the vector between the 2 same coloured arrows, the greater the leading or lagging power factor. The numbers to the right of the phasor diagram are streaming electrical parameters for each phase. The last 2 metrics on this table are PQ, or power quality, which is reactive power divided by total power, and PQR, or power quality rating. PQR is calculated using power factor, total harmonic distortion, and phase load balance. PQR is a representation of most of the major factors influencing the quality of power. The facility being monitored in this video is currently paying for 100% of the incoming energy, but only is using about 30%, the real-time PQR value, as electrical power. The remaining 70% is being lost as heat or vibration somewhere in the power grid. Below PQR is a diagram displaying the active power in watts, followed by a display of the total harmonic distortion, measured in percentage value. And finally, the power quality graph measures power factor of all 3 phases independently. The green line on the power quality graph represents the power quality rating. These diagrams show historical data for approximately the past 300 seconds. One of the groundbreaking advancements in software-defined electricity is direct measurement of electricity. Direct measurement requires a combination of 2 innovations: a software-based processor-agnostic computing methodology and intelligent sensing. To correct and balance electricity in real time requires all data processing to be completed within 10 nanoseconds from data acquisition. The Vector Q is fully digitized for total operational control, and software-based, processor-agnostic computing allows for processors to be added in parallel when additional processing power is required, or for processors to be turned off to save electricity when they are not. Using this advancement in computing and direct measurement of electricity, the Vector Q leverages the mathematical principle of oversampling to guarantee perfectly synchronized, error-free data from the point of acquisition. Combining these innovations, the Vector Q can push electricity analytics to real time, which is to say precise data for all parameters, at all times, as electrical power flows. Many modern power compensators lack the embedded intelligence for visibility, meaning they lack the ability to perform precise electrical corrections in real time. Instead, they rely on compensation. To demonstrate compensation, we will turn on a bank of capacitors. See the phasor diagram as all 3 phases shift equally. If this amount of compensation is needed for a relatively static load, this would have a positive effect on energy flow. This is in no way correction. The power flow to the loads is still non-optimized, as is visible in the current distortion, harmonics, and other numerous power quality issues still present. Watch as all 3 phases shift again as the capacitor bank is turned off. For comparison, the Vector Q comes with a technological advancement in controlling electrical power flow by performing real-time correction of reactive power, harmonics, and phase imbalance simultaneously. For the purpose of this demonstration, we will use a unit which allows correction to be enabled and disabled on demand. Consumer vector Q units do not have this feature, and it is shown here only for demonstration purposes. Watch the phasor diagram when the vector Q is enabled. Current and voltage on all phases is now synchronized, and the load across each phase is balanced. Watch again as correction with the vector Q is disabled and then enabled once more. The current waveforms shown here are clean and sinusoidal when the vector Q is enabled, and distorted and imbalanced when the correction is disabled. The same is true with harmonics seen here. Without correction, the distortion level is high and aberrational, but when the vector Q is enabled, the distortions are decreased significantly. Finally, take a look at the PQR just under the phasor diagram. Without correction, as you remember, the facility is buying 100% of the electricity and using only 30%. With the vector Q enabled, the usage reaches nearly 99%. Please take a few moments to note the changes in power factor, total harmonic distortion, and phase balancing as the vector Q is enabled and then disabled. The installation process of the vector Q is performed by a licensed electrician in less than 30 minutes and does not require power to be interrupted. The unit must be close in proximity to the panel and needs to be secured to the support structure, usually the wall, using the provided screw holes. Wires must be connected to suggested breakers and installed on all three phases. 2 additional wires must be connected to neutral and ground. Lastly, 3 current transformers are attached on each incoming phase of power for sampling. With precision metering, elimination of harmonic distortion, correction of the power factor to near unity, and the most complete usage data and analytics available on the market. The Vector Q Series Intelligent Power Controller is a cornerstone technology for providing clean power and network protection. Contact us for more information and to get started on a bespoke solution for your unique power needs.